So let's get things kicked off. So Tableau software overview. What is Tableau? It's a self-service data discovery and analytics tool that leverages your brain's natural abilities to recognize visual cues, provide quick access to data, and has an intuitive design interface to create interactive visualizations and dashboards that attract attention and drive insight. Okay, so it basically helps people see and understand their data. So just a quick exercise here. For the next 15 seconds or so, see if you can count up the number of 9s that are in this entire block of numbered text. Alright, so there's actually 9 9s this entire block of text here. Obviously it's much more difficult to count when they're not called out. This is called attentive processing because you actually have to be attentive and figure out what you're looking to analyze and count it. So if you look at the next slide, we're looking at pre-attentive processing. So essentially we're able to quickly see and point out what's different in the mix of things, which is much easier for our brains to analyze visually versus looking through a whole set of numbers and trying to figure out what's different. So using colors, different shades, sizes, and orientation, we're able to quickly see differences in our data and visualize them, and that's Tableau's strong suit. If we take a look at the top half of the screen here, we have some sales data on a month-to-month basis, and if you just ignore the bottom half of the screen, if you try to visualize that trend in your head over time, it's much more difficult than you would think. What happened 3 months ago in May? It's very, did we go up, did we go down? But once you actually see it visually, you could see how certain months will spike up or downward, allowing you to quickly drill down and see what caused those spikes and get some real root cause analysis. Like for example, technology in November, there's a huge spike there. So what happened? Why did the sales increase so much? And you can leverage a tool like Tableau and quickly drill into that data and see what caused that spike. So you're telling a story versus actually looking at raw numbers. The beauty of Tableau is it's establishing this new culture of self-service analytics. Traditionally, IT has been responsible for both creating the data stores, loading it up, also churning out the reports they thought the business had asked for. It turns out, these weren't the reports they were expecting. Things need to be tweaked. So it's constantly this back and forth between IT and business, and obviously there's tons of red tape involved. So Tableau's mission is to empower the business and leverage IT where needed, so the business can then ask their questions directly using a tool like Tableau and no longer need to rely on IT for the report generation aspect. They will, however, still need IT for staging their data and making sure it's cleansed and following best practices, but from a reporting standpoint, that should be in the hands of the business. There's tremendous gains from time savings and cost when the business is empowered and has the ability to make their own decisions versus relying on IT constantly. So as far as the Tableau product line goes, there's 4 core offerings. Tableau Desktop, which I'll demo for you in just a short bit. That's the primary tool where you're going to be creating your visualizations. You can integrate your data sources within Tableau, combine multiple sheets into dashboards, and it's very easy to use. No real programming is required. Tableau Server is a product that Tableau offers that allows your organization to essentially save on a server your Tableau dashboards and share those across the organization, allowing you to quickly and easily access dashboards whenever needed, even on your phone. Basically, that's the big selling point. So once you do get desktop installed, Tableau really pushes for organizations to roll out Server because you're really not able to understand the true value that Tableau offers to an organization without having it be widespread. If you just use Tableau Desktop and you're creating visualizations, that's great. Like they're local to your machine. People can come to your desk and check them out, but actually having them out on that server and being shareable is where you experience that true value proposition. The next offering is Tableau Online, which is essentially Tableau Server, but Tableau will host that in their cloud. So they handle all the the maintenance, the upgrades, the administration, and that does obviously come at a cost, but it does allow you to quickly scale up and test out the Tableau server software versus trying to bring it in-house, purchasing the hardware, and obviously the team to sustain that. And last but not least is Tableau Reader. Tableau Reader is a free piece of software that Tableau has pushed out that allows you to essentially open up Tableau packaged workbooks that are exported from Tableau Desktop. You can't edit them because you'll still obviously need Tableau Desktop to make changes to these files, but it allows read-only access. So if you do want to share something, much like you would share an Excel spreadsheet, you would send that to someone, and they can open their the workbook within Tableau Reader. All right, so some key strengths of both Tableau Desktop and Server. Faster data access through Tableau. Development is a breeze compared to going back and forth with IT, and the time to actually realizing and understanding the insights that you're getting from your data is much, much shorter. Tableau Server provides a central location for governance, security, and collaboration, like I mentioned. So what makes Tableau so great? It's completely interactive. You tell a story with your data. It's fun to use, so you're constantly trying new things. Oh, let's look at data this way. Let's just drag this in, and oh, I don't like that. Let's undo. Maybe add some color. So you're quickly and easily empowered to interact with that data. It's self-service with a very short learning curve. I would say within a month's time you can be pretty proficient with Tableau as long as you're using it on a daily basis. And again, minimal IT is involved, so the business is really empowered using this tool. As far as the development perspective goes, it's very agile. I'm sure many of you have heard of agile versus waterfall. So you can easily iterate on your dashboards. It's not going to impact anything outside of your local machine. They're very high performing. So Tableau has their data extract technology that shrinks down the size of your data source as well as greatly increases the read performance. And I'll get into the Tableau data extracts in a little bit. Also, you can connect to your data real time. If you want to plug directly into your database with your Tableau workbook, you can always see the latest and greatest version of your data, and it's pretty much real time. And you also have the ability to share your dashboards. So you can package those along and send them over to your colleagues, and they can then open them up with Tableau Reader. Or you can obviously go the server route, which comes at a cost, which I would recommend. All right, what makes Tableau not so great? It's not built for operational reporting. A lot of times I'll see clients basically creating reports that look similar to an Excel spreadsheet, and Tableau really struggles with rendering these because when it's actually drawing the data on the screen, it has to clock and figure out the best way to display it, and it really chugs on numbers. So I would strongly recommend you to not build spreadsheet-like reports and really try to go for the visualization aspect. And again, like Tableau actually limits the number of columns that you can display in a table. Right now it's at 6. You have the ability to expand this, but things start to get a little hokey. You'll see some of the columns start to sort of concatenate with each other columns, and it just gets messy. So I would strongly recommend you would not exceed the limit of 6, especially for performance reasons. It's definitely not a robust ETL tool. Tableau can paint a lot of pretty pictures and tell great stories, but it's not so great at transforming and joining data. It's just a struggle, so I highly recommend you do any transformations outside of Tableau before you decide to bring that data in. Tableau can't crank out highly formatted reports, so if you think of something like a utility bill or a cellular phone bill, Tableau can't create those. It can just create a chart that's specific to the certain data set at hand. It's not going to allow you to print out a ton of beautiful, highly formatted reports. You'd have to doing that in other tools like Crystal Reports, which I'm sure many of you are familiar with, and Tableau does not do anything like that. So frequent software updates can be a real pain with Tableau. They always want you to be on the latest and greatest. So for example, if one of your colleagues is working in the latest version, Tableau 10, and they want you to take a look at their dashboard, and you try to open their workbook up, it's going to say error, cannot open file, and that's because you're on version 9. So it constantly pushes the fact that everyone needs to be on the latest and greatest version, which can be a pain for some users, and especially a lot of organizations that are trying to remain consistent, be on the same version across the board. And it's definitely not as easy as advertised. You'll find that it's easy to get lost in Tableau. There's 15 different ways of doing the same thing. So light SQL knowledge is definitely recommended. If you don't know how to do something, obviously you just pop that into Google and someone else has probably already asked that question. That's a great resource. And you'll have a lot of moments of how did I build this last week, and just trying to recreate what you've done is difficult, but once you do it a couple times, you'll get it. Okay, some key terminology. Within Tableau, you have a Tableau workbook. Think of this like an Excel workbook. You could have multiple tabs at the bottom, all of which represent different sheets, where you then create your visualizations. And I'll show that in just a second. And you create, the Tableau workbook is created when you save your workbook within Tableau Desktop. And this workbook contains, in the back end, the database connection info and the location of where your actual data is being stored, but no physical data is stored inside of that workbook. So it's basically a pointer with connection information that says, hey, look for this data here, but it's not part of this file. Tableau has worksheets, like I mentioned, much like an Excel worksheet, which is used as a canvas for your data visualization. Worksheets consist of dimensions, measures, and then an assortment of different ways to draw your data using shelves, pills, and marks. So when you're looking to calculate your reports, you're using a dimension, so something like a year, a state, or a product, and a measure is something you're trying to measure or analyze, much like a quantity sold or net sales, and you would base your measures on a particular dimension. For example, net sales for a certain year. So let's pop into Tableau. So down here on the bottom, we have a new sheet icon. So we would click that, and it generates a brand new sheet. So you can see how these tabs are very reminiscent of an Excel. And like I mentioned, we have our dimensions and our measures. Tableau is smart enough to automatically figure out, based on what a particular column contains. For example, we're using a spreadsheet for this data set. It analyzes that column, tries to understand what the type of data is being run through that, and automatically associates a certain data type to that field. So currently it's calculated that all of these are dimensions and all of these are measures, because these are probably numeric and these have text. So we have our dimensions, our measures, parameters, which I won't get into in this, they're a little more advanced, but and we have our columns, our rows. So we're basically dragging and dropping different dimensions and measures to create our visualization on the canvas we're seeing down here. And again, we have our marks, and the marks allow us to change the way data is being displayed on our canvas. So if you wanted to tweak a color, you can do that. The size, labels, certain chart details, as well as tooltips, which are a neat little hover over right here. So let's go back to, okay. Dashboards are a collection of multiple worksheets. So like what I just demoed, the canvas, you would have multiple canvases on one canvas. So you're basically taking all of these worksheets that you want to see in one view and consolidating them. And that's what a Tableau dashboard is considered. Tableau also has this feature called Stories, which enable you to take different snapshots in time of your visualizations and allow you to share your analysis with your colleagues. Think of it like a PowerPoint slideshow within Tableau, where you can say, okay, well, you can add captions and text, and there's a spike because of this, so you can actually walk someone through your whole train of thought and tell that story using your data. Tableau packaged workbooks are very similar to Tableau workbooks, with the exception of they actually contain all of your data. So, for example, if you wanted to take all the information off of a database table, bring that onto your computer, you can do that, obviously within reason. And then it would all be part of that one Tableau package workbook file. So if you had, a million record database table, you pull that into your local machine, Tableau wraps that up into its packaged workbook, and now you have that entire database table in your Tableau package workbook file. So you can go hop on a plane, and you can still mess around with visualizations that are part of that database. And like I mentioned, the Tableau data extracts. Data is stored in a highly compressed format, optimized for performance, and it's a snapshot of data at a moment in time that you actually pull that extract. This screen looks a little different than the one I just showed you because Tableau just updated their software, I believe, yesterday to version 10. So I'll probably struggle a little bit creating the visualizations because they have changed a lot of things around substantially, actually. You can see here again, we have our cards and shelves, our data window, which is this left pane with our dimensions and measures, your toolbars, and the Show Me panel, which I'll demo in a little bit, which essentially allows you to pick different chart types based on the dimensions and measures you have selected. And this is a more zoomed in picture of the actual canvas where you're creating your visualizations. This is the header section, and then you have your individual panes, and then you have your axis. All right, so getting data into Tableau. Data prep is not exactly Tableau's strong suit. So if any of you have seen Office Space, this is Bill Lumberg. Yeah, if you can go ahead and also do that data prep, that'd be great. So Tableau can create joins between tables, but they don't perform very well, and it causes a lot of issues when you're trying to visualize, and if anything drops or changes, it breaks your entire visualization. So I'd highly recommend that you do not do your joins inside of Tableau. Maybe during the prototyping phase, that's fine. You can also create calculated fields on the fly based on your existing fields. This is all well and good, but it does cause performance to suffer because Tableau is calculating all of this information in real time whenever it's rendering your charts. So I'd highly recommend that you would move your calculated fields to the database, in particular in like a database view. So you can work with IT and have them integrate those in the view that you create, or they create rather, that you're going to be using as your source for your Tableau visualizations. And like I mentioned, it's much better for performance if you move a lot of that legwork onto the database, not into Tableau. And obviously much better for your mental health and stress levels because it can get quite taxing when it comes to trying to troubleshoot issues inside of Tableau. All right, so live connections in Tableau versus extract connections. Live connections are essentially a real-time access point to the latest and greatest version of your data, but it does have trade-offs. It's only as fast as the underlying source, so you can't expect just because you have Tableau now that your database will automatically read data faster. It won't. It still relies on the underlying structure of your database. Also, when you have live connections to your database, it's constantly requerying, so every time you apply a filter or things are being calculated, it's running queries and hitting your database. So you're adding a load that might take it down if it gets great enough. And obviously, if the service is ever interrupted, you would lose your connection and all the data that's attached to that workbook until it comes back online. So that might cause issue when you're trying to actually build and develop in real time. So I'd recommend perhaps taking an extract off the database, only hitting it once, capturing it all locally, storing it on your local machine, and building using that. So Tableau data extracts, snapshot in time, like I mentioned, much better performance, stored locally, best for aggregated data sets. So don't try to extract 2 billion plus record tables. It probably will crash. And you can schedule your extracts to refresh on a recurring basis. So much like traditional ETL nightly load cycles that run, database can be refreshed nightly. You can now also schedule your extracts to refresh based on whatever time interval is necessary. So now it's time to do a little walkthrough. But before we get started, I'll just go over some points here. So if you're looking to download and install Tableau, obviously you can get the latest version from their website. Historical versions are also available at the link provided, tableau.com/ESDALT. And the reason why you would sometimes want a historical version of Tableau, for example, if your organization is currently running Tableau Server 9 and Tableau 10 is the only version you can download off of their website. If you go to their homepage, you need Tableau Server 9 because without 9 you can't publish to your enterprise server, which is currently on version 9. So you want to make sure you're always on the same version level on desktop as you are on server, 1-to-1. But if you don't have server, go ahead, download the latest and greatest from the website. Connecting to data, Tableau can natively connect to pretty much almost every data source. The most common ones, SQL Server, Oracle, Excel files, CSV files. And for the full list of Tableau support data sources, you can go to tableau.com/solutions/data sources. And there's probably 250, I would say, out there now. It's pretty crazy. You can connect to almost anything. You're hard-pressed to find something you can't connect to. And oftentimes, you might need to install a database driver on your machine to support that connection between Tableau and that database. So I've also included a link here, tableau.com/support/drivers. And that will allow you to access any drivers that are necessary for your database. All right, so what we're going to cover in the live demo, I'll be showing you how to connect to a data file and load that into Tableau, build some basic worksheets, some charts, apply some filters, as well as create some calculations. And we'll also look at building an interactive dashboard, adjusting the size of that dashboard. I'll show you how to add various objects like text and pictures, and how to get the most bang for your buck out of your dashboards. All right, so with that, we'll get started with webinar exercises. So in our first exercise, we'll be analyzing some student enrollment metrics. So we're looking at the number of students by sector. So I'll go ahead and just connect to our new data set here. And like I mentioned, these are some of the sources that Tableau can connect to get data. So we're using an Excel file. And this is the Georgia IPEDS data for the Tableau training today. Okay, so this first screen, it can look a little overwhelming, but it's essentially just showing us what's currently in our file and how Tableau had categorized those fields. So I'm not going to go into too much detail on all of this, but if you'd like to, you can change the way these data fields are coming in. Maybe you want this to be a decimal and it's not looking proper, so you can come in here and do that. Or if a field should be a date and it's not, you can also update that within this particular drop-down. So once you're all set with that, you go ahead and just click on Worksheet 1, and we'll get started. So I like to label all of my sheets just so I know what I'm working on, because if you have sheet 1 through 15 and you're trying to figure out where that one chart was, you'll be hard-pressed to find it. So I'll just rename this to W1 for Worksheet 1, A, and then num students by sector. Okay, so we have our measures on the left-hand pane here, and these contain all of our numbers. And I know this field, all undergraduate fall, contains the enrollment numbers for everyone in this data set. So if I add that by double-clicking, Tableau throws it into a bar chart because it assumes I want to see my data this way based on the algorithm that it ran through and best possible way to show this data. And now if I want to see this by sector, I'll just double-click on sector, and it automatically creates a bar chart for us and puts sector here on this bottom axis. And again, instead of double-clicking, you can also just click and drag into columns. So we can see here that the vast majority of enrollment is in public, almost overwhelmingly. Next is not-for-profit, and finally for-profit. So that's all great, but I actually want to see this in a percentage instead of the actual counts. So what I'm going to do is I'll hit Control, click and drag on this pill. These are called pills. and drag it and drop it onto label. So I'll just undo. The control option, when you press on your keyboard and click on a pill, it just basically copies it instead of moving it. If I were to actually take, for example, sector institution and put it on color, we can see how immediately it flees from the column shelf. We don't want that. So we'll take the sum, drag on a label. So now we have the counts, so 1.7 million for public, and right now we're going to be analyzing it as percentages. So let's go ahead and add another measure down here. So we're not replacing anything, we're just adding one additional, and currently it's not being mapped to any of the marks. It's just set as detail, which means it's just sitting in the background. We're not using it as a label or as a size metric or color. And we're going to right-click on that. And this is going to give us some options of how we want to see this particular measure. A very handy thing down here is quick table calculation. You can see the Tableau has predefined multiple table calculations that we can quickly and easily add to this particular object. And we'll use a percent of total. Okay, so this little triangle pops up, and that means that we're currently using a table calculation. And now I'll just click and drag this onto label. And now we can see the Tableau has added right below the count the percentage makeup of that. So practically 3/4 of the enrollment comes from public. 17.3 for not-for-profit, and for-profit it's around 9%. And if you wanted to change the formatting of those labels, you just go to Label, click on More, and much like you're used to in emails or Microsoft Word, you can bold, you can change the font size, the font, and Tableau will automatically change directions of what's being displayed based on what the current space is looking like on the screen. So I'll go ahead and just readjust that, drop it back down to 8.
I'm a vice office. I know.
Okay, so bar charts are great, but let's now look at this as a bubble chart. All right, so definitely a lot more surface area right here, so we can probably add labels and it'll look a lot prettier. But you can see that public is overwhelmingly larger than the other sectors. So we'll add in, again, our labels. So I'll hit Control on the color one, just so I'm grabbing a reference, but not changing the color. And again, I'll add the percent total. Right-click, quick table calc, percent total, and we'll just drag and drop that again on label. So this is an example of a packed bubble chart. The overall size of the circle is based on what's currently on this particular circle mark for size, and that's the all undergraduate metric right here. So based on what the values are in this particular measure, it changes the size of these circles. So obviously for-profit has the smallest number. All right, so next up, let's take a look at enrollment trends by sector over time. So visualizing data over time now. Enrollment by sector over time. So we'll add in our sector, and then we'll add in our all undergraduate fall. So now we have no real time in here, it's just showing us all of our data. We'll add in year. So now we have all these numbers, much like we saw in that example where we had the Excel data on top and the charts on the bottom. So now we'll go up to here where it says Show Me, and this is where Tableau helps guide you and point you in the right direction. And based on what it's seeing, as far as what measures and dimensions you're using, it'll suggest different chart types for you to use. For example, a line chart, a tree map. And if you don't want any of these charts, you can hover over the ones that are grayed out, and Tableau will tell you exactly what you need in order to get those charts to show up and become usable. But for this example, we're visualizing a trend over time, so obviously we want to use a line chart for that. Okay, so here we have a breakdown by sector over time. We can see this top one is public. Next is not-for-profit. And on the bottom is for-profit. So you can quickly and easily see where these spikes are occurring. So between 2012 and 2013, there's obviously something occurring where the public enrollment pretty much skyrocketed. And the not-for-profit remained pretty flat overall. And if you wanted to see a little bit more of the variation between these two particular bars, we would have to exclude the public from this view. So watch what happens when I go ahead and right-click on public and exclude. So Tableau re-renders the visual and allows us to just zoom in on what's relevant. So currently all we have is the for-profit and not-for-profit. So down here in for-profit, you can see quite the spike, whereas not-for-profit remained pretty steady the entire way. So pretty powerful stuff how you can quickly and easily visualize your sectors over time and identify certain spikes. Okay, so next up, let's take a look at enrollment by gender. So W2A, enroll by gender. So this data set actually does not have a gender field, so we're going to have to derive one based on the measures we currently have. Tableau has this feature called pivot, which will allow us to take multiple measures and actually create on the fly a brand new dimension based off of those measure values. So for this example, we're using gender, but because of the way the data is structured, I'm also going to incorporate races as well. So I'll highlight all races and genders by control-clicking to multi-select. Okay, I think I got them all. And I'll right-click on any of these that I've selected, transform, pivot. Now on the top here we can see there's a brand new dimension called pivot field names. I'll just right-click and rename this to gender/race. And down here we have a pivot field values. So I'll rename that to gender/race values. Okay, so since we're just looking at the enrollment by gender, we'll add in gender/race to our filter, and we're going to be excluding everything that's not a gender. So we'll just click on female and male. Okay. And we're not going to be using the all undergraduate fall numbers anymore because those no longer tie to this dimension. We've created a brand new set of values using this pivot feature. So I'll double click on that, and now we have the overall totals, but it's not broken out by gender. So we actually have to add gender to our canvas. So now we have a female and male bar chart, which breaks out the difference in gender and enrollment. So females clearly have quite a commanding enrollment lead versus males. And if you wanted to visualize this, see in a packed bubble, for example, you can see the size comparison between the female population and male. And then now let's add the percentage values so we can actually see something here. So we'll take the gender race values, drop it off at the bottom again, and we'll click and drag that just so we get our counts onto our circles here. And again, I'll add another version of this, and this one will be the percentage total. So right-click, quick table calc, and percent of total. And we're not seeing it yet, and that's because we haven't yet told it to add to a label. So we'll click and drag onto our label, and Tableau will throw it down there for us. So we can see that the female population is around 60%, whereas the males are around 40%. Next up, let's take a look at the enrollment by gender over time to see if there's any real fluctuations in that. We'll create a new sheet. Okay, so again, adding in gender. Actually, we'll filter out the races first. So only keeping female and male. Adding in our gender race values. And this time we have to add our time dimension for year. And now we're seeing an overall trend. It's currently not broken out by gender, so there's just a combined. But if we want to split this out, we can either click and drag on gender race onto color, or just do the old control click onto color, which copies the field. And if you wanted to make these a little more relevant from a color standpoint, you can just click on, right-click, edit colors. We can make the female, for example, pink, and the male blue. And I also like to sometimes get rid of all this white space down here. You can see that the chart currently starts probably around 103,000. So if we right-click on our axis, choose Edit Axis, you have the option to include zeros or not. So let's go ahead and just get rid of that and hit OK. And it drops down all of that white space and really allows you to see on a much more zoomed in scale of how these lines are changing over time. So now that we've analyzed gender enrollment data, let's take a look at the race enrollment data. And let's also visualize it by sector as well. Okay, so again, we're using our dimension. We're filtering out what we don't want to see. So we'll select all except for gender. Adding in our totals. And we want to see this by sector. Okay, so currently we're looking at the overall total for all of our races, but let's say we want to break this out and see each race individually. We would have to add races up here to our columns. So now we have a visualization that shows us on each bar what the makeup was for public, not-for-profit, and for-profit. If we want to assign some values to these, we can just go on the gender race values, add our labels, or we can just replace that and make it a percent of total. And you can change the way this is being computed, so you can change the percent total. Instead of being across the table, you can make it go down. So each individual column will now represent the overall based on what's the sector breakdown. So for example, you wouldn't want to see this in a bubble chart. There's way too much going on. So certain chart types you just wouldn't want to analyze data with. So you can always quickly undo, and Control Z does the same thing. Or you can redo with Control Y, or redo. All right, next up, let's take a look at the enrollment by race over time. We know we need our time dimension, gender race values, and we have to remove everything that's not a race. So we'll get rid of the gender. Okay. But we're still not seeing all of the races in their own separate lines. So we have to tell Tableau to draw different lines. And we'll do that by assigning the gender/race field to color. So now we have a breakout based on race. We can see up here on our legend what the overall enrollment was over time. So if we hover over, we can see on each particular mark. So on 2011, the enrollment was around 150,000. 2012, around 144,000. Next, we have our Black or African American category. And down here, it's kind of difficult to see any trends because it's so tightly compact. So I would recommend actually removing both the white and black race from this visualization. So let's go up to our filter, edit, and let's just take out white and black. And now watch what happens. All those tightly compacted lines are actually showing quite substantial trending. They were being overshadowed by the other two values, white and black. But here we can see that the race, ethnicity unknown, which is this purple line, is drastically dropping. This may be due to better systems of record that are now capturing races whereas they weren't before. We can see that the 2 or more races category has been steadily creeping up. And there's been a sharp increase in both the Asian and Hispanic enrollment in the past 7 or so years. And if you wanted to add labels to these, just click on label, and based on what's currently up here in the rows, it'll populate those. You can see it's a little busy, so I probably wouldn't recommend showing labels on this busy of a line chart, but just in case you wanted to add them, you could do that here. All right, next up, let's take a look at some financial aid charts. So W4A, financial aid by sector. So we'll add in our institutional grant aid, add our sector, and let's throw this into a packed bubble chart. So you can see that the not-for-profit has substantially more financial aid when compared to a for-profit. Let's add in the percentage here. Quick table count, percent of total. Yeah, so over 75% of the institutional grant aid is in the not-for-profit sector, followed by public and for-profit. Next, let's see how this has trended over time. W4B, and we'll call this financial aid by sector over time. Again, adding in our dollar amount for overall financial aid. This time we'll do our year. And right now, we only have one line, which contains all 3 sectors. So if we wanted to split those out, again, just drag that onto color. And now we can see that there are definitely some pretty good trends going on here. From 2011 to 2012, it looks like the not-for-profit substantially dropped their financial aid numbers, while the public has increased substantially right there. So that's analyzing the financial aid by sector over time. And next up, let's take a look at some graduation metrics. So W5A, do 6-year versus 8-year grad rates. So now we're going to be creating some Tableau calculations or calculated fields. For this first one, we'll be calculating 6-year grad rate. So we're taking our number of students that have received a graduation award, and we're dividing that by the total 6-year cohort. And you see I'm just clicking, dragging and dropping these particular measures into the calculation window, and Tableau automatically recognizes that these fields are over here. Say we were to add a space here. You can see that it's turned from black or from orange to black, and it says this calculation contains errors. So Tableau will automatically notify you if your formulas are ever broken. So you can also just type it out, and Tableau automatically suggests fields that fit that particular criteria. Okay, so let's go ahead and add this to our chart. And right now it's just a sum. Obviously we want to look at a percentage value, so we have to average this. And right now they're still in decimal format, so in order to change this field to show as a percentage, we'll right-click, come down to Default Properties, Number Format. And very similar looking screen from what you probably have seen in Excel when you're formatting your cells. We would go to percentage, and we can leave 2 decimal places, that's fine. Okay, so this is our 6-year grad rate. Let's go ahead and now calculate our 8-year grad rates. And we'll calculate this the exact same way as we did for our 6-year. Number that received an award, and we'll divide that by the total 8-year population. Okay, now that we have that, we'll make sure this is also converted to a percentage. Default Properties, Number Format, Percentage. And I'll go ahead and now add this to our rows, and I'll change that to an average. So Tableau has now stacked both of these measures, but let's see them both together. In order to do that, we have to come down to the lower of the two, right-click, and choose Dual Axis. That then consolidates both of our measures onto the same chart. But they're not quite lined up yet. You can see how the 25% is over here and this one's a little lower, and that's just based on what the overall values that this field has. So the makeup is a little different from both of these fields, but we can also synchronize them. So we'll go ahead and right-click and choose Synchronize Axis. So now we can see that Tableau has synchronized both these axes, and it looks like the overall is climbing up to about 40% from 38%. And now let's look at this by sector. By simply adding sector to our columns, we now can easily see how each sector has performed from the 6-year to the 8-year mark. And because these circles are not looking the greatest, we'll just come up here to all, and this is saying for whenever you go into the all mark, it's going to update both this mark and this mark, or these two measures rather. So I want to change all of those from circles to something like a Gantt bar. So now we can see that the smallest jump from the 6 to 8 from grad rates is in the for-profit sector, followed by the not-for-profit, and public seems to have the largest. So in 2 more years' time, this many more people were able to graduate. All right, now let's take a look at some non-graduation metrics. So people that transferred, ended up no longer enrolling in school, or decided to, are still enrolled. So let's go ahead and create this now. We'll call this W5B 8-year non-grad metrics. And I'll be creating 3 new fields for this. The first will be 8-year still enrolled. Clicking and dragging that and dividing that by the overall cohort. Making sure we're using the percentage. And now I'll just go ahead and just double click on that and throw that into Tableau, making sure it's averaged. Okay. Next up, we'll do our transfer rate. So students that enroll in another institution, divide that by the overall. Again, changing the default properties to be a percentage. And you see what happened when I double-click that. Tableau automatically threw it up to the top instead of the rows. So I'll just move that down, and I'll change that to an average. And lastly, we'll look at the stop-out rate, or students that no longer decided to pursue a degree. Percentage. Okay, so it looks like the vast majority of individuals decided to completely stop schooling and just try other things in life. They just decided not to finish pursuing their degrees, closely followed by students that decided to transfer, and then we still have some students that are still enrolled. And if you want to see this by sector, we simply add sector to columns, and now we can see how the different metrics vary by sector. So for-profit tends to have the highest number of students that decide to no longer enroll in school. The not-for-profit tend to have the highest transfer rate, and the public have the highest number of students that are still enrolled. Okay, so let's do one more sheet, and then we'll start creating dashboards. So in this sheet, let's take a look at the 8-year grad rate. And this time, we'll view it by institution. So here we're seeing all of these different schools and what their graduation rates are. Right now it's sort of all over the place because it's being sorted based on alphabetical order. If you want to change this sort order, we would come up to institution name, right-click, sort, descending, and we would base that on the 8-year grad rate field. So now we have this pretty downward sloping series of bars that indicate the 8-year grad rates by institutions. And this might all look well and good, but a lot of these schools might not even have that many enrollees, so it's quite easy to reach that 100% rate. So if you wanted to see the number of students that were actually enrolled, I believe it's so yeah, you can see here that the Luther Rice University, although they have a 100% grad rate, their enrollment rate is quite low, so it probably is pretty easy to hit that number. Probably the best one that I'm seeing right here is University of Georgia, who tons of enrollees, and right here 85% grad rate, which is really, really good. So you can see how you can compare two different sets of data and back up your analysis pretty easily and quickly. So now let's take a look at how to build the dashboard. So I've been creating just worksheets. That's what all of these are down here. And if you wanted to jump over to this next little box called the dashboard. So now that we're in our dashboard screen, we have this prompt here that says, please drop sheets. Okay, so let's say we want to add the enrollment by sector over time. You can either double click on it or just click and drop it right here. And let's add another one, enroll by gender over time. And you can see how Tableau automatically starts moving things around, reorganizing the space of this overall canvas. Let's say we wanted a bigger dashboard. You come up here to the size. Currently it's on 1000 by 800, which is the desktop browser height. You could change it to a custom width and height, or choose from a predefined selection. Let's go ahead and choose generic desktop. Maybe that's too big. We'll go a little smaller here. So laptop browser. Okay. So you can add any number of worksheets you'd like. Obviously, if it's already added, it won't add another copy of it. You can see by this little blue check mark that indicates that the sheet is currently present on this dashboard. We'll go ahead and add in financial aid by sector. And then let's do 8-year non-grad metrics. So Tableau automatically, based on the size that we have here, has stored all these different visualizations. They're currently not talking to each other, though. In order to get these visualizations to talk to each other, we have to add a filter. We have the ability to add a filter on anything that's currently in this dashboard. So we'll click on this little caret icon, this little drop down. Filters, year, gender, race, and the actual values. So say you just wanted to suppress certain sets of values, you can do that as well. But let's add in gender/race. And I'll add in all of them in this particular chart. So you can see how it automatically updated. I can deselect, for example, black, just gets removed from that visualization. Male, gone. But nothing else is being updated. If we wanted this to talk to all of the other visualizations as well, we can do that because they all share the same data source. So if we go to Apply to Worksheets, you can either do Selected Worksheets and individually select which worksheets you'd like this particular filter to apply to. So let's do all on this dashboard. Okay. So let's say, for example, that we wanted to remove all Asian students from our analysis. It would update the visuals based on that. How about removing all Hispanic students? So you can see how you can easily add and subtract certain metrics from your visualizations. You can also add in pictures. So let's go to Image. And I'll just choose this random image here. And again, Tableau is putting all these images where it sees fit in all these charts. But let's change that. So currently we're looking at a tiled version of a dashboard. Let's go to floating. So we could either start fresh on a new one or modify this one. I'll just show you what happens when you start changing things to floating. Floating. So it essentially removes them from being snapped to the background grid and allows you free-form control to resize and move around different charts. I prefer floating because it gives me more flexibility when I'm creating my dashboards. I don't like to be tied down to certain areas of a chart. So if we go create another dashboard here, I'll just show you how the difference in floating versus tiled works. Okay, so now that this particular chart is out here, we can see that it's not really using the entire square. So I'll just click and drag, but it's still not using this section. So you have to do the fit option. Fit. You can do fit width, fit height, or entire view. If you do entire view, Tableau then re-renders that visual to always use as much of that box as possible. So that comes in handy. And let's say we want to add more filters that aren't currently in this particular worksheet. So right now it's just gender and race. Let's say we want to add in a historically black college or university filter. And let's also add an institution. And I'm going to enable us to use all the different filter values. So now that we're back on our dashboard, I want to add in those two filters. So I, again, click on this little drop-down, filter, historically black college or university, and I'll also add in the institution name. You could change these because this is taking up a lot of space. I'll just do a quick change the filter drop-down to a multi-value drop-down, but it's still quite large. So we have to manipulate the way it's being laid out on the screen by going to Layout, and here we have the X, Y, and the width and height of this object. The height is way too big, so I'll just default this to something like 45, and you can see that it's now in a more reasonable size. So now you can pick and choose which colleges you'd like to keep and how it affects your analysis. And the same goes with this historically black college flag here. So if you want to only look at ones that were, you can see that most are public, whereas ones that aren't are not for profit. So that's a quick overview of how to use Tableau to build worksheets, dashboards. You can add text. All right. Okay, so that's how you build dashboards in Tableau and pull in multiple worksheets and allow them to interact with each other.